Hello, welcome back. Today we are going to be using what we have learned with solving one-step equations, and we're going to use that to solve one-step inequalities. So our objective for today is I will be able to solve one-step inequalities. So as you may or may not recall, an inequality are the following symbols. We have less than or equal to, greater than or equal to, just greater than, and just less than. So solving one-step inequalities is very, very similar to solving one-step equations. There's just two extra things, and one of them I will mention here. So step 1, draw a line through the inequality sign. Step 2, use the inverse operation to isolate the variable. Step 3, draw the number line, and step 4, check your work. And just as a reminder, I know that we're pros at this, but just as a reminder, the division, the inverse of division is multiplication, the inverse of multiplication is division, the inverse of addition is subtraction, the inverse of subtraction is addition. So just as a refresher, to graph inequalities on a number line, this is the process that we use to do it. Please write this down. Okay, please write this down. So when you have a less than or equal to sign or and a greater than or equal to sign, you need a solid dot. Okay, you're going to use a solid dot, and this means this value is included in the solutions. And then when you have an open dot, you're going to be using the greater than or less than sign, and when it's an open dot, this means the value is not included in the solution. So let's take a look at an example so we can look at all of those steps that we just talked about, including the graphing. So we have x plus 8 is greater than 2. X plus 8 is greater than 2. I'm going to get my pen here working. Yep, there we go. Okay, x plus 8 is greater than 2. So, draw the line, step 1. Step 2, we have 8, a positive 8. We have to ask ourselves, what is the constant, positive or negative? Positive 8 is our constant, so we need to subtract 8 from both sides to get rid of it, or to isolate the variable. All right, that leaves us with just positive x. Bring down the inequality sign. We have 2 minus 8. Okay, 2 minus 8. So keep change flip. That's the same thing as writing 2 plus negative 8. Okay, to solve this, we have to go negative 8 or 8 minus 2. 8 minus 2 is 6. Take the sign of the bigger number. So negative 6. Okay, so now we need to graph it. So take a step back for a minute. X is greater than negative 6. So that means in this solution, the solution to this inequality, the solution means that any number, x is any number that is bigger than negative 6 is going to be a solution. So let's take a look and let's see that on a number line. So to graph it, I require at least 3 points. Negative 6, or your solution is going to be the middle point. Okay, then do one below and one above. So one below negative 6 is negative 7, and one above negative 6 is negative 5. Okay, next look at the sign. This is a greater than sign, which means an open dot. X is greater than negative 6. Well, because x is greater than negative 6, that means all solutions bigger than 6 is going to work in this inequality. So we need to draw an arrow from this dot to the right, because as we move to the right of the number line, that means it gets bigger and bigger and bigger. So all x is equal to all the solutions bigger than negative 6, but not negative 6, bigger than negative 6. Let's check our answer. So when we check these, when it's greater than or less than, we want to do what the sign says. So x is greater than negative 6, so we want to check something that's greater than negative 6. So let's check negative 5. Negative 5 plus 8 is greater than 2. So negative 5 plus 8, so 8 minus 5 is 3, is greater than 2. Yes, it is. So that works. We would be able to do the same thing with every single real number is greater than negative 6. It would work. That's why we're using this inequality, because it's not just one solution. It's a whole bunch of solutions that are bigger than negative 6. All right, let's take a look at our next example. So now we have 12 is less than or equal to y minus 2. So let's take a look. First draw the line. We ask ourselves, is this constant positive or negative? Negative 2, so we need to add 2 on both sides to isolate the variable. These cancel out. That leaves us with y is greater than or equal to 12 plus 2 is 14. Draw the 3 notches. 14 goes in the middle, and then do one below and one below. So we have 13, 14, and 15. Okay, now let's look at the sign. We have a less than or equal to sign, so we need a solid dot above the 14. Okay, we have 14 is less than or equal to y. So since 14 has to be less than or equal to y, that means y is greater than or equal to 14. So because it's greater than or equal to 14, that's why we draw the arrow to the right. So with these checks, we can use the y value that we found because it can be equal to. So 12 is less than or equal to 14 minus 2. 12 is less than or equal to 12. Because it's equal to, that does work. Okay, you could plug in anything bigger than 14 and it would make it true. Let's take a look at one with a fraction in it. Okay, so we have x plus 2/3 is less than 3/4. First, draw the line. We subtract because 2/3 is positive. These cancel out. We get x is less than 3/4 minus 2/3. So let's rewrite it. 3/4 minus 2/3. We need to find a common denominator. 12 would be our common denominator. Okay, so 4 times 3 is 12. 3 times 3 is 9. 2 times 4 is 12. I'm sorry, 3 times 4 is 12. 2 times 4 is 8. So 9 twelfths minus 8 twelfths is 1/12. So x is less than 1/12. Okay, same thing, draw the 3 lines. We're just going to do 0, 1/12, and 2/12. Okay, since it's just less than, it's an open dot, and x is less than, so this time we're drawing our arrow to the left. To check our work, we want any number that is less than 1/12, so I'm just going to use 0 because it's easier to work with a whole number. So 0 plus 2/3 is less than 3/4. So 2/3 is less than 3/4, and now let's take a look at these common denominators to check ourselves. So we have 8/12 and 9/12. This is indeed true. Let's take a look at another one. 1/2 is less than or equal to 2 minus 1/5. So we need to add 1/5 from both sides to both sides. These cancel out. That leaves us with t is greater than or equal to. Okay, now we have 1/2 plus 1/5. Okay, let's find a common denominator. 10 would be our easiest one. 2 times 5 is 10. 1 times 5 is 5. Okay, same thing. 2 times 5 is 10, and 1 times 2 is 2. So 2 tenths plus 5 tenths is 7 tenths. So 7 tenths is less than or equal to t. Draw our 3 notches on the number line. So 7 tenths is in the middle. Our answer is in the middle. Okay, then we're going to do one below, so 6 tenths, and one above, 8 tenths. Since it's a less than or equal to sign, it's a solid dot. 7 tenths is less than or equal to t, so that means t is bigger than 7 tenths, so you need to draw the arrow to the right. To check our work, make it easy on yourself. So 1/2 is less than or equal to, let's do 1. 1 minus 1/5. Okay, let's just make it easy on ourselves. So we have 1/2 is less than or equal to 1 minus 1/5 is 4/5. Okay, to find a common denominator to make sure we already know this is 5 tenths is less than or equal to, and this would be 8 tenths, and that is true. Alright, so here's our special rule when we're coming with inequalities. The special rule is when you multiply or divide by a negative number, you have to flip the inequality. So this is a part that I think it takes a second to remember it, so please, please, please go slow when you are multiplying or dividing, just to be sure that you are catching this. So here we go, let's look at an example. So we have negative 5m is greater than 35. Draw the line. So since it's negative 5 times m, you need to divide by negative 5. This is what I mean. When you divide by a negative, you're going to flip the sign. So instead of it going this way, you're going to flip it. 35 divided by negative 7, or negative 5 is negative 7. Okay, draw the 3 notches. Negative 7 goes in the middle. Negative 8 is bigger, or is smaller rather, and negative 6 is bigger. Okay, it's a less than symbol, so the dot is open. M is less than negative 7, so the arrow goes to the left. To check your work, you pick any number that is less than negative 7, so let's just pick negative 8. So negative 5 times negative 8 is greater than 35. Negative 5 times negative 8 is 40, is indeed greater than negative 35. Okay, now let's look at this one. We have x divided by negative 2 is greater than 4. Okay, so x divided by negative 2, so we need to multiply by negative 2, x, and then we gotta flip the sign because it's a negative number. 4 times negative 2 is negative 8. Okay, so we have negative 9, negative 8, negative 7 is an open dot. X is less than negative 7, so the arrow goes to the left. To check your work, you pick anything less than negative 8. So I'm just going to pick negative 10 to make it easier. A nice even number divided by negative 2. Negative 10 divided by negative 2 is 5. 5 is indeed greater than 4. Okay, the same thing happens with fractions, or if it's positive, you do not have to flip the sign. So let's take a look. When you divide, x divided by 1/3 is greater than 12, so we need to multiply by 1/3 on both sides. X is greater than, it's a positive 1/3, so we don't flip the sign. 12 times 1 is 12. 1 times 3 is 3. 12 divided by 3 is 4. So we have 3, 4, and 5. Open dot because it's a greater than symbol. X is greater than 4, so greater than goes to the right. So check your work. You pick anything that's greater than. So let's just do 5. 5 divided by 1/3 is greater than 2. Okay, so to undo that, you do keep, change opposite, and then we have 15 over 1. So 15 is indeed greater than 12. Okay? I know I did that one pretty fast, but we are going to be doing more examples, and I'm hoping that this starts to make sense to you guys. So take a second, try these two problems by yourself. Okay, if you have any questions whatsoever, please write these down, and we are going to be moving on and practicing these skills for a couple of days before we move on. So I hope that, thank you for diligently watching and taking good notes, and I will see you later.